Now, cash flow diagrams, or CFDs, because I'm too lazy, CFDs are simply pictorial representations of costs and benefits. So if any of you have taken, is it okay to use Casio FX300? I don't know. If FX300 is on the syllabus, any variation of that is fine. But if it's not on the syllabus, then the answer is no. So go look at the syllabus. Okay, so if any of you have taken physics, or yes, no problem, or statics, like if you're a civil engineer, you would be familiar with something that is called a free body diagram. So I would say that cash flow diagrams, although much simpler, I promise, than free body diagrams, are similar in a way of just like how to visualize things. So they're similar to a free body diagram. So what I mean by that is what you're going to do is like have like a timeline, for example. You'll say, here's year 0, like today. And then you've got like year 1, 2, 3, 4, really? Year 5, 6, 7, 8, 9, for example. Okay. And so you might say, well, at year 3, I had to pay $50. So you would go to year 3 and you would draw an arrow down and you would label it at $50. I like to color code it, but you don't have to. For me, it's nice because I'm like, red is bad, green is good. So $50 is representing a cost at year 3. Or let's say you made $100 at year 6. Someone handed you a $100 bill. You've got an up arrow at year 6, and you would label that $100, which represents some sort of benefit at year 6. So that's what I mean by representing just a pictorial representation of costs and benefits. So you would translate like a problem statement to a picture like this. So last time we talked about different definitions of things. Remember, we went over like first costs and operations and maintenance and salvage and all those different definitions. So let me show you what they look like in terms of if we were to draw it. So a first cost is happening today, presently, right? So it's a cost, so the arrow is going to go down and it's going to be at year 0 because it happens instantaneously. It's the first thing that you do. And so this is how you would draw first cost. And let's say you had a salvage. Remember, salvage is a benefit at the end of its useful life. So it's what you sold that product for, or what you think you can sell that product for. So it would be an arrow up. That's how you would draw salvage. And then let's say you had an operations and maintenance cost. Now remember, we said that that is a reoccurring cost where it happens like every single year. It's helpful to connect the dots to tell your audience that they're all the same. And then you would label it as O&M, operations and maintenance cost. is one that we didn't go over last time I saw you, which is called an arithmetic gradient. What does the word arithmetic mean?
Math.
Math. Yes. Arithmetic. Yes. What does the word gradient mean?
There's a slope of some sort.
Yeah, some sort of slope. And so what an arithmetic gradient is something that kind of starts at like a 0 mark and it increases linearly. Okay, so let's say it started at 0, but it went up by some regular rate, like it could be like $25 a year or something. You made $25 more every single year, every year. Now, you could have an arithmetic gradient that's also a cost, right? It could start costing nothing and then increase and increase and increase as well. So you should note that cash flow diagrams, they depend on your perspective. What just happened to my pen? That was so weird. Oh, is it always linear? Yes. I mean, in this class. Of course, you could have any expense that follows any function, right? But if we're referring to a gradient specifically, a gradient is linear. It's like, you know, when they talk about like a sidewalk as a 2% slope, you know, it's the grade of the sidewalk. So what I mean by depending on your perspective is, are you the borrower or are you the lender? Because cash flow diagrams, your green and your red are going to flip. So if you're the borrower, maybe you take a loan out. Let's say it's your school loan. You're going to get an influx of money at the beginning of your loan value. But then maybe it's deferred, but after the deferment, you have to start paying on it, right? So once you start paying on it, it's every year or every month, whatever the stipulation is. So you have to pay each time some sort of amount to start paying back what you borrowed. So let's call those, let's say, annual payments. Now, because of interest, it's never perfect. So like if you borrowed $500, it's not like you just make 5 payments of $100, right? It's never perfect because of interest. So when you're ready to pay off the loan, you always have to like call them and say, I'm ready. I want to pay it off. What's my like final balance? And they'll say, okay, you owe us $100 to like close. So to truly close a loan out at the end, you would make like your final payment to finish paying off the loan. We can look at the same situation from the lender's perspective. When they loan you the money is leaving their account. So that arrow goes down instead of up. And in their mind, they're calling this an investment. Then every time you're making your payments, they get that income. So in their perspective, they are making annual income. And when you call and say, I'm ready, I want to pay off my loan, they tell you, okay, well, you owe me X amount of dollars to finish paying it off. So that final payment that you made is also income for them. See the difference? Big difference. It depends who you are, what perspective you have. It definitely changes things, right? Your costs become your benefits and vice versa. Okay, so that's where we left off. And now today we're going to do some examples. Example 1. The cost of maintaining, and this is important because this lecture we're just learning how to draw them, but then the next lecture we'll learn how to do the calculations. So make sure you actually write this problem down because we're going to go back to it and refer to it and do the calculations later. Okay. The cost of maintaining a sewer line is $20,000 in year 1 and increased by 2,000 each year until year 8. Draw cash flow diagram. So we've got from year 0 to year 8. So we've got a cost that starts at $2,000 or $20,000 in year one. So you're going to draw an arrow down here, 20K. What would it be in year two?
$22.
Very good. 22K. And then what?
24.
Yes. And then?
26.
Okay. Next.
28.
Next.
30.
Next.
32.
And last.
32.
34. Okay, so yeah, so that is one way to draw it, but you could see how that would get really annoying if we had like 100 years. You wouldn't want to do it that way, right? So alternatively, you could just sort of draw it like, I'm just going to use the different colors so you can see. Like, you could draw like the first arrow here, and remember we talked about annuities and gradients, right? So you could say basically that base is some annuity worth $20,000, and then I have a gradient which has a slope of 2,000. So you could have drawn it like that. And then perhaps maybe only label like the first one and the last one or something. Okay, that would be acceptable so that you don't have to draw each arrow. One thing I want you to note is that although we drew the first arrow at year one, everything starts at 0 in the sense of we're using an end of year convention. So we're saying like, okay, you got this service and now you pay up at the end of that year. So from year 0 to 1, you were using it, and then you made a payment like right in the instance of year one to pay for that previous year's service, whatever it might have been. So we're using an end of year convention. So the first arrow you draw is at 1, but that's counting from 0 to 1. So maybe make a note. The triangle and the rectangle. So each start at year 0, but you see them drawn at the end of the payment period. Questions about that? All right, number 2. Again, we're going to come back to each of these examples and do calculations next time. So make sure you write the examples down. A firm is deciding between 2 machines. One will save the firm $300 per year, and the other will save $400 the first year, but will decline $50 per year. Each device costs $1,000 and has a useful life of 5 years. Draw both cash flow diagrams. What does the G stand for again? Gradient. So if you go back to when we first were learning, remember we talked about an arithmetic gradient where it was linear. That's what the G means. And the A is an annuity, where it's like that, like basically a rectangle. If you see a rectangle, it's an annuity, like the O&M cost, for example, so you wouldn't have to draw each arrow. And then if you see a triangle, that's a gradient because it has a slope. So to draw for machine A, we have 5 years. And how would we draw the $1,000? The cost of $1,000, where would we draw it and how would we draw it?
That's our initial cost.
Very good. Down at year 0 because it's an initial cost of $1,000. How about that 300 per year? How do we draw that? Up at every year. Okay, starting where? What's the first year we draw the arrow? 1. Good. So you could draw an arrow of at each year of 300, or like I said, you could just draw like the first one and the last one and kind of connect the dots, and that implies that there's the same arrow everywhere, and then just label it as 300. So either one's acceptable. When you're drawing this many arrows and lines and things, I'm just going to remind you to look at the syllabus because it does talk about using a straight edge. Okay, let's try machine B. So it still has the $1,000 cost at year 0. But what would we draw at year 1?
$400 up.
Good, 400 up. And it would go down by $50 each year. So you'd have like $350, $300, $250, 200, something like that. You could kind of like connect the dots to show that it's linear. Questions about that? Number 3. Scale A costs $2,000, has a useful life of 6 years, and will save $450 per year. Its salvage value is $100. Scale B costs $3,000. Has the same useful life. The heck? But will save $600 per year. Its salvage is $700. Draw both cash flow diagrams. So for scale A, our years should go from 0 to what?
6.
Good. What do I do about that 2,000?
Arrow down at 0.
Good. How about the 450?
Arrow up at 1 to and connect it with 6.
Good. How about the 100?
Arrow up at 6.
Good. Questions about that? What should I label the first red arrow for scale B? $3,000. How about the annuity?
$600,
And the salvage?
$700.
Very good. Questions about that? Deck construction. Data below. Draw both cash flow diagrams. So we have N. Wait, let's see. We've got brick. And wood. So we're deciding between a brick deck and a wood deck. And the useful life is 30 years versus 10 years. The first cost is $1,800. Versus 450. And the O&M is $5 a year. Versus $20 a year. So for the brick, we've got 30 years. So it goes like 0. We'll have to mark year 1, and then maybe we can just say like mark like 10, 20, 30 or something like that. What do I do with the 1,800?
Arrow down.
What year?
1.
Year 0. So first cost is actually at instantaneous year 0. So that's 1800. Where do I put the 5?
Year 1.
Year 1. Arrow down. And it continues the whole way for 30 years. $5. So here's the thing. We're trying eventually to decide, like, which deck should we buy? Should we buy the brick deck or the wood deck? Now, the wood deck only lasts 10 years, whereas the brick deck lasts 30 years. Okay, but the brick deck costs more in first cost, but then the brick deck is less maintenance, so it's like hard to tell, right? Well, in order to even make a decision here comparing brick and wood, when we draw the cash flow diagrams, we have to be comparing apples to apples. So because wood only lasts for 10 years, then we still have to put it over a 30-year lifespan and then just replace it every 10 years. Okay. It's kind of like thinking of like a common denominator. Like you can only compare them if we're looking over the same lifespan. So we are going to still draw a 30-year cash flow diagram for the wood. And, you know, it does have a first cost. Where should I draw that?
Year 0, and every year you want to redo it.
Right. So at year 0, definitely 450. And it also has that maintenance cost that we talked about, which is just 20. But every 10 years you have to replace it. So you would have a first cost again at year 10, and you would have a first cost again at year 20. Because you have to keep reinstalling it every 10 years. Stack your arrows on top of each other like I drew them. Don't like draw it on the inside of the rectangle. Stack it on the outside. How come there isn't a cost of 450 at year 30? Great question. Well, we didn't replace the brick deck at year 30, right? We bought it once and it lasted, and then it was at the end of its useful life at year 30. So we had to keep buying the wood deck at year 0, year 10, and year 20, but we're allowing it to expire by the time it reaches year 30. We didn't have to buy a new one because we're trying to compare them to last up to 30 years, and that's it.